Welcome to this xbim webinar today. So I'm Andy Ward, I'm Chief Exec at xbim. Thanks for coming along to the webinar. Just to give you an introduction about what we're going to do. I'll give you a quick overview of what xbim is about, what xbim Flex is, our platform. Talk about some of the use cases, and we're going to focus today on efficiency, savings for the industry, offering new services. And we'll also do a couple of examples of how some clients have used our platform. And then what's the run for today is probably 15 minutes of demos where we'll be showing, Flex Flow, which is our automation engine. And I'll explain what that's about. It's essentially an automated means of working with BIM data to turn it into something useful. And that's so I guess today what we're looking at is, how can we take some of the hard work out of working with building data? Going to go through a couple of use cases. First one, just making use of BIM data files. Secondly, making sure that data is fit for purpose using a new standard called IDS, Information Delivery Specification. And lastly, we'll do a quick demo of how you can conduct a carbon assessment from BIM data using some third-party carbon databases. I will show a couple of other use cases as well, but they're the main live ones. So to kick off, if you don't know about us, xbim been around for about 15 years. We've got a lot of experience in the BIM sector, particularly open BIM. Our background, where you may know us from, is something called xbim Toolkit, which is a software library to work with open BIM, IFC, Kobe, BCF, and the like. It reads and writes all those formats and makes them useful, particularly in a Microsoft world, where you're working on in perhaps Windows or desktop-based software. And then we've also got xbim Flex, which I'll introduce, which is a cloud enterprise platform for working with BIM and asset information model data at cloud scale, with kind of collaboration, security, and so on. So we're probably about 10 strong, UK based, but we're sort of spread around Europe. We're funded by a VC firm, so we are in kind of growth mode, particularly around xbim Flex. So Flex is just to give you a little bit of background on it, our platform for developers. It's kind of cloud native rather than being a software library, so it's agnostic with different technologies. It's built to be secure and scalable in enterprise. It's one of the challenges you look at is where is my data? How can I take control of it? We've got a lot of capabilities around that, so you can manage building data in the cloud with a lot of governance and security around that. And essentially, it supports BIM, asset information models, and all the way through different life cycles into even digital twin use cases. What we've really done is take what's a very complex domain of managing building data and simplify it into something that you can use as a software developer without needing an intrinsic amount of BIM specialisms, and particularly open BIM specialisms. We're all about open formats, open data, because we think that's in the best interest of clients, and it gives us longevity. It means clients can work with their data for the next decades rather than the next couple of release cycles of the piece of software they work with. So broadly speaking, what Flex does, you'll see this in video form a bit later on, is take data out of the design world, tools like Revit, into open formats. That's where Toolkit comes in, because Toolkit can read and write open formats, open BIM, IFC. And Flex takes it to the next level, where we cloud host all that and manage it in essentially a data lake. So really what we're doing is taking better building data out of the on-premise world, through Toolkit, and then turning that data into, those files into data and geometry, stuff you can visualize, information you can work with. And Flex over here is really turning that into a big cloud of data, lots of models. So as a client, you can look across all your projects, or as a systems integrator, you can work with many clients and manage individual projects and so on with access rights and controls. And it handles all the gnarliness of federation and so on. And today what we're talking about a lot is xbim Flex Flow, which is really a kind of a sibling to Flex, which is our automation engine. Essentially to handle kind of automating some of these flows in a way that doesn't require humans in the loop. So Flex, and for those, apologies if anyone was on the previous webinar, this is probably common stuff. Essentially, we've got about 6 core technical modules in our Flex platform. So we manage all the hosting and the management of that platform, the patching and updates and so on. But the core capability is around AIM, asset information management, automation of BIM workflows, the visualization of 3D and 2D, and that's wrapped up with a collaboration engine so you can communicate, and clearly a lot of things like security, identity management, access control. And additionally, we've got some real-time capability and hooks into other software such as Revit and design tools. And we've got some rich hook connectors into the Microsoft ecosystem, particularly things like Power BI. So it's a whistle-stop tour of what we do. We're going to go through some, today we're really focusing on perhaps the automated workflow and to some extent AIM modules in Flex. And I've probably covered this already, but essentially, if you cut us through, we're all about open data, open BIM. We have open APIs, which essentially means it's very easy to integrate with our software platform. Ultimately doing that because we think it's just the best for the built environment. The most value is obtained across contractual boundaries and so on. So, and if you're not familiar with it, so it's the Building Smart Standards, IFC, and the like that we really help support. And our clients typically end up being software vendors or technology specialists who are building BIM products, and we end up being built into products such as, to give you a couple of examples of partners, Benchmark Estimating, use xbim Flex in their cost estimating and carbon estimating services. It's actually a Windows application, but it's powered by the cloud. And so what you're seeing in here actually is xbim, xbim Viewer and xbim Data, and it's Flex data behind the scenes. I guess what they came to us was they had a gap in their portfolio. They had a very mature costing platform and carbon platform, but what they couldn't do was BIM-based quantity takeoff. And so we were able to kind of really efficiently plug that gap and integrate a new BIM quantity takeoff service that hooked into their costing engine. And I guess the intelligence in there is that, for instance, they work with a lot of things like highway schemes, where those schemes need to be re-estimated or perhaps even redesigned with different options every 6 months, and they didn't want to have to take off all those quantities again. So there's a smart mechanism so they could determine what's changed between different versions of a design scheme, and they can recost at different intervals without going back to drawings and so on. Secondly, I've got another case study which is for Fexelon, who actually were using xbim Toolkit, but really wanted to kind of get more value out and was perhaps struggling with the scale. So they came to adopt Flex, which really gives them a kind of a scalable, mature cloud platform that spans both BIM and into digital twins, which is where they're offering services. So they have a lot of major tier 1 data centers, hospitals, infrastructure clients where they manage, or essentially providing an asset management service. And clearly Flex was a massive accelerator there. What you're seeing here is Flex white labeled into their SaaS product. So let's just give you a couple of partner and ideas of how partners use us. What we're going to do today is look at sort of efficiencies and how and perhaps new service offerings and how you could integrate Flex and Flex Flow into your services today. And just to give you a couple of ideas, kind of use cases, there's loads. This is almost limitless use cases that you can derive value from in using a service like Flex. But on the contractor and supply side, it's things like, how do I validate building data that I've had from my design teams, my subcontractors? How can I get quantities out of those building models, bills of material? How can I do those higher order things like when you undertake carbon assessments? If we've got, we're working collaboratively, how do we resolve issues? And how do we handle that change management concerns? How can we see what's gone on since the last time we received these building models? I guess on the other side, perhaps less so today, but this is ultimately why we're doing it, is for clients, so they can look at, take building data that's come from the supply side and use it in use as an AIM or digital twin, where they want to manage those assets and so on in use. They want to use that that building topology in their own services, in their own other records, or in their own internal IT systems, and they want to maintain that data over life. And ultimately, they want to make that data much more useful to their stakeholders, their end users, and their businesses. So we're going to look at some of these use cases today in a bit more detail, particularly those on the left. I think the last webinar we were running a series, was around digital twins, and we talked a bit more around the use cases on the right. So we're going to show some demos. The first one is one I actually ran last time, but just to recap broadly what Flex does. So I was going to speak to this kind of recording of what we did. And essentially, it's how do we get data out of a proprietary tool like Autodesk Revit. Let me just increase the resolution on this. Here we have a plugin into xbim Flex, into a Revit called our Flex add-in, where we are essentially be able to take a prescribed view, a 3D model, but also associated other resources, drawings, save views, schedules of information, floor plans in this case, and then extract it from essentially the proprietary world, and as a coherent package, export it into our cloud platform as an open BIM model, but also a linked set of drawings, views, and schedules. So here we're taking that same 3D model, which is a federated model, and show you we can cut it from the drawings. We can recreate some of those save views, and we'll see here we can inspect data just ad hoc, but later on we can actually do things more prescriptively with that data. So we're looking at Kobe data in this case on a chiller. You've got cost of replacement, warranty schedules, and so on. This here we're going to bring up actually a schedule of, I think it's rooms, so it's a Kobe room schedule below the 3D drawing, and it's linked to the BIM. So if I go and locate a room here, the waiting room, I can show you where that is, along with all the properties with that. And I think what we're going to do is just scroll down a little bit and look for the mechanical room, and just identify that. We should search for it normally, but I think we're just scrolling for it. Locate the mechanical room, and then we'll cut to perhaps that second floor so we can see it better, and then click the room, and we'll be able to zoom to it. So it's a fairly basic collaboration capability, but it's all come within 10 minutes of exporting it from the native authored format. You see, it's compared with something like Revit, it's a very simple, collaborative, cloud-based way of working your way around a model. So I just wanted to kind of highlight really quickly a 2-minute demo of taking data from the proprietary world into the open BIM world and being able to collaborate around it and get data out of it that's useful. What we're going to do, the focus of today is really on Flex Flow, and that previous demo is actually the core Flex platform. So Flex Flow is an automation rules engine, and our kind of hypothesis here and our inspiration is actually from the software world. And we're all software engineers actually in xbim, we're predominantly software folks. And I've cast my memory about 20 years. It's very hard shipping software. It often involved CDs and long painful processes to get software out the door. And a Google engineer called Jeff Humble came up with the concept of it hurts to more often. Very much a lean concept, and it's something that we think we should apply to BIM. If things are painful to do, whether it's quality checking or things like a carbon assessment, try and automate it. If you and to do it more often, you need to automate it, and that's where an engine comes in, an automation engine. And so the inspiration here is the software world, where the continuous integration came in to try and solve this challenge of how do we get software out the door. Software is a bit like a BIM. There's a source to it. There's a design process that goes on, and then there's a number of steps you need to do to hand that over essentially into a form that end users can make use of. And this flow at the top is a representative of what tends to go on in the software world, where a code change triggers what's an automated process that will say, okay, that code's changed. Let's go and acquire it from its repository, its source of truth. Get the kind of dependencies we need to work with it. Make sure it's all versioned. We may stamp it with some version numbers. Check it meets our local standards. turn it into something that's actually executable, test it, package it all up, send it out somewhere so that people can see it and use it, and perhaps actually do what we call a smoke test on it to make sure it, it meets the brief. And ultimately, we can produce reports that may indicate the exception, the variations from what we expect. So the end of it, what you end up with a new version, and no one's really been in the loop on that. The developer made some code changes, and some new software was pushed out to a test environment. And that's a really common practice now across the software industry. We're taking complex computer models and turn them into working software code. And we think that's for BIM really is a similar problem. That how do you take design data and at regular intervals put it through a standardized process so that you can have a common output that hasn't had to have a human in the loop. They may make errors, miss things. So what we've tried to determine here is a process that how can we take building models and put them through a user-defined workflow. So in the case of a BIM, an IFC model, we want to acquire that model from its source, get essentially some fundamental dependencies that might be the requirements, the EIRs. We want to version it according to 19650. I want to check some basic conventions. Is it named right? The format's the right versions and so on. And then turn that model into something we can go and use. So we need to turn it into a semantic model, into some geometry, and then perform some tests on it. So if the client set requirements, or if there are stage gates we need to get through, how can we automate that, and how can we essentially give it a red, amber, green categorization? Finally, kind of output the results from that so you can visualize it and see it, potentially follow up and do some more interesting things like quantify and so on. Final QA, maybe things like federation testing and so on, and ultimately notify stakeholders, BCF issues and so on. So that's the kind of a real kind of what we're trying to do here with flow. And at the end of that, you're turning files, turning them into data, turning them into geometry in a high quality fashion that's automatic, user definable, repeatable, and independent. That's really what FlexFlow is. So that's what you're going to see here. So it's a user-definable means of building these kind of workflows, and they can actually be very simple. So I'm going to show you a really simple one, and then I'm going to show you some more complicated versions. So first example here is just turning a model into data and geometry. Okay. So this is xbim flow. We've defined a workflow, and actually a workflow is a script. It's in a language called YAML. Fairly simple. It's going to run a C# script that's about 10 lines long, and we'll turn that model file into data and databases and 3D geometry. So there's an API for this, although I've just dragged and dropped a IFC model in there. And if any of you are working with Toolkit, it's the kind of processes you might, and particularly in the cloud, you'll be doing this in the background somewhere. We've just packaged it up into a service, essentially, a workflow. So in theory, you could there's an API you can call, upload a model to this workflow, and it'll put it through this process. And it's a single node process in this case. So it's just going to go and take an IFC model and turn it into some outputs. Those outputs are, as I mentioned before, it's things like geometry. So we've gone and done the geometry processing. We've also turned that BIM into a database. We've extracted attributes, property sets, and so on into a database. And lastly, we've gone through and generated some xbim files. Xbim is the xbim 3D format, a bit like GLTF or OBJ, but it's optimized for BIM. So here we generated some pre-built xbims and some databases that contain everything that's in that building model. And that's done with a single step defined workflow, but it's much more powerful than that. So really, it's that's just scratching the size of it. Really, it's a single. In theory, we could do all kinds of processing in there. We could select certain elements for processing. We could manipulate the building model before we've uploaded it. We could validate it and so on. So that's what I'm going to show you next, is how we can go and validate building model data before you've processed it. Okay, so we're going to, before you brought it into your system, you can give it a sniff test and make sure it makes sense. So I'm going to introduce a new concept here called IDS, which is a new standard from Building Smart. I'm not going to spend long on this today because I've got a whole webinar on this in a couple of weeks' time. IDS, Information Delivery Specification Standard. So it's a new Building Smart specification going through ratification right now. and its purpose is to provide a nice, simple, consistent way of defining rules that a client may expect their model data to adhere to. So it standardizes a lot of those kind of rules checking processes, particularly very much around the semantic data, the information in a building model. And it's perhaps a third part of that trinity of IFC, BCF, BIM collaboration format, and the kind of specification that makes sure that IFC delivered meets the client's brief. So I'll get the right video here. Where is it? I'll just bring it up open separately because I should be in the deck, but it's not there. Bear with me. So give you an idea here. So this is let's pause this briefly. Actually, it's one of our xbim partners web service that lets you define an IDS specification. So the use case I've got here really is really simple one. I want to make sure that all spaces in my building model are classified according to a classification scheme. In this case, unit class 2015 spaces and locations table. And it's defined really quite simply, and it's a kind of it's a very simple data model. I'll go through this much more in a couple of weeks. Where if I open this up, we're saying, okay, find me all spaces in that building model, and it could be much more sophisticated than that. You can also say, you could filter by all kinds of different elements and properties and materials and certain relationships in that model. But in this case, all the spaces, and then we're going to go and check, ensure it's got a unit class classification. So we want the classification system to be unit class, and we want the values to match SL, which is spaces and locations, a couple of numbers, so we know it's in the right format. And essentially what that's built at the end of it is a file in a defined schema by Building Smart. It's got the same data in there, so it's defining the applicability, which is, so this rule applies to spaces, IFC spaces, and again, typically they can be more complex, and there'll be a series of requirements, hundreds possibly. And then for each space, we're then putting it through a requirement that's saying it must adhere to match a certain pattern in terms of the value, and the classification scheme is unit class. So that's the file we built, and essentially what you can see in use within xbim Flow. So again, we've got a pipeline, a workflow we've defined, where it's going to go and run one step, which is to run this spatial script. The spatial script is going to validate an IFC model against an IFC file, and that IFC file is called spatial IDS, which you've defined and uploaded in that workflow. You might have seen also there, it's also going to generate BCF files at the end of it. So here, I'm again doing it manually. I'm going to upload a model just rather than sending it via an API, and it will process it. So it will take that model. It will before we load it up or do anything else, we're going to go and scan through it and run those rules against it. And so it's actually fairly quickly gone through, identified 22 spaces in that model, and 21 of them passed the requirement and 1 of them failed. And also what it output there was a BCF file, which will have that issue in there. So I've just switched over to our ComSat, and we've loaded in that BCF against that same model. And here's what you can see is that Lakeside IFC model in our collaboration tool. And we've highlighted, this is the one issue where the waste room had no classification against it. And you'll notice here, looking at just hovering over it, it's got some properties, but it hasn't got a classification. In fact, what we'll do is we'll switch over to a different application. Again, looking at the same data. So you'll see those 22 spaces, 22 rooms. And if I'm going to put in here, it's just a couple of the extra fields. So I've looked up classifications, bringing the identifier, the identifier name. And I guess you'll see very visually that waste room has not got a classification. Equally, it could have been if it's classified with a value that wasn't SL, it would have picked it up. And this is the simplest of rules we could have done. The point is, it's a really kind of standardized way of determining rules. Here I'm just drilling in just to show you, take another room, one of the toilets, just to show you that toilet there it met the expectation that there was a classification identifier of SL, something or other with some numbers. So that's really simple verification, but it's it's got a nice kind of feedback loop because you can define those rules engine, those IDS scripts, and reapply them and upload all your upload your models iteratively and over again, and it'll put it through that engine. It'll give you a red, amber, green traffic light report, and it'll spit out BCF BIM collaboration format issues where there are defects. So you'll see a bit more verification in a minute. We're going to do a different verification. So let me speak now to carbon assessment. So our kind of third use case here is a more complicated one, where we're going to conduct an embodied carbon assessment using, taking open BIM models, but we're going to use a third party set of data sources. So we're going to make some API calls out to, in this case, co-builders product data templates and some material databases, so that we can automate the process of conducting a carbon assessment. The schematic, we did this with co-builder, was a webinar for them a couple of weeks ago. The purpose, the idea is we can take data from its source formats and put it through a workflow. In this case, we're going to validate it. We're going to do some more interesting validations. So we're going to check, because we're looking at material quantities, we want to make sure that things like the openings and walls have been cut, so we're not or we haven't duplicated elements within that building. So there's an element of clash detection we're going to do. Then we're going to go and get some data templates, product data templates. And particularly, you may have product data where we know exactly what things like carbon, embodied carbon is. So for instance, a door or a window may come from a particular manufacturer who's provided that data. So we can look that information up quite authoritatively and say, this is the embodied carbon impact of that particular product selection. But then separately, what we're going to do is look at other elements like some of the building materials, particularly walls and the fabric of a building, and determine what quantities are in there, what materials are in there, and then do a carbon assessment on those materials. And ultimately use both these bits of information to enrich a model, add essentially the global warming potential to that model, and push it back into Flex so we can go and have a look at it. That's quite a complex workflow, which is this is how it works. So this is the end result of it. So I'm going to start with the end. So here we are. This is a model that has been put through the workflow. You'll see here the output from this is a BIM model, and we're also showing you the embodied carbon in kilograms on a sort of a color scale here. You'll notice it goes from -108 to 260. Actually, there's some negative values in there because of timber products, and we'll see that in a minute. But if we set the classification to be 0 to 261, so we can see where we can make most impacts. You'll see now that the hot spots are really in red. So this is where our higher elements are. And if you see on the tooltip there, you'll get an idea of what materials are in there. It's gypsum, plasterboard, and so on. There may be concrete in some of those constructs as well. So that's just poking around and having a look at the model, but we can also look at a schedule of that. So look at all the quantities we looked at, the individual elements, and their embodied carbon. You're seeing here, we select an individual wall and it'll flag it up. Here I've flagged up the element. An element has got a negative quantity. We select on that quantity, it'll take us to it, and then we can press Berlin and have a look. Okay, so it's a timber wall. That kind of makes sense that possibly there may be a positive global warming impact. So that's the kind of output from it. So the magic on how that happened, this is it. So essentially going back a step, this is a workflow that does the previous work from the previous flowchart I showed you. So first up, we're doing some verification, some sanity checking on that model. We're checking it has got doors and windows and so on in there. We also look for some duplicated spaces. We did clash detection on it. We determined actually there's some overlapping walls in there. You don't want to fix those because you'll be double counting your quantities when we take off the volumes and so on. Then you'll see it's really quickly flowing through, and it's done a lookup from CoBuilder to extract some properties from CoBuilder. We've done a material takeoff. So we've gone through all the elements in there and work out their volumes and break them down by material, element by element, essentially. And ultimately, we've produced some data. That's both a material takeoff in CSV format and a list of the issues, which are those duplicated walls. And then finally, we've enriched that model and pushed it back into Flex, and we saw that earlier. That was the Flex comms demo. So this clicking on that link will take us back to that model I showed you earlier. So that's the execution of a workflow. A more sophisticated one this time you saw is 4 or 5 stages, and even those stages themselves, as you'll see, have sub-stages within it. And so this is the definition of that workflow. And this is actually an editable workflow. So we can go in here and edit it in real time. But here's one we defined, and essentially you're seeing here the sanity checking, where we did a script to check, for instance, has it got walls and windows? We've got another script that does class detection, that just checks that certain building element classes aren't overlapping with each other, and then we output the results, basically any issues we found. That's why you saw the red cross in the previous example. Here we're going off and enriching it, and we're going off to a couple of external services, GoBIM and CoBuild to define, and the script makes use of those services and calls in to get things like embodied carbon quantity, EPDs and the like, as well as material quantities. You'll see, so that's the material takeoff, and then this point here is we're doing essentially the last piece where we take those material quantities, cross-reference with the product data templates and material database, enrich the model with the outputs, and then produce a report that goes off into xbim Flex comms. So this is the bit that actually generates and publishes the output model so that you can inspect it, share it with your colleagues, and so on. So that's really quickly going through 10 or 15 minutes of some of the things you can do with Flow and xbim Flex. The other thing I'll just highlight here is everything you've seen there, we're showing you model by model, but our platform is really quite sophisticated in terms of its kind of portfolio approach. So as a client, an end client on this, you can be looking at across all your projects of all your models. And in this case here, we're looking at a University of State campus, in this case spatially, but it could be in terms of components and assets in that building. And so we're looking across, 15 or 20 different building models in a Power BI dashboard that's behind the scenes is speaking to xbim Flex and it could be looking at what is it looking at areas. It could also be looking at carbon costs or financial costs or so on, and reporting at a high level what's been going on across all of your projects. And that's showing it graphically, but clearly it could be in more kind of chart style reporting and so on. So that gives you a kind of really high level view of what's going on in the world. On the last one, I'll just quickly flag up a capability. I won't show it live, but we've got the ability in Flex to do design change controls. So essentially we can look at 2 different versions of a model, version A of a model versus version B of a model, and ask the question, what's changed between those 2 points in time? So that really gives a report back and saying, what did we lose? What did we find? What's new? What's been matched and what is potentially matched? In this case here, it's suggesting that, okay, in this room here, we lost 3 items of furniture, and we found in green, and in green we found 3 items of furniture. But probably more importantly, it's finding all the things that are the same, so they're coherent, and you could start to, track what has really changed between these 2 items. So here, what we've got is the doors and in that building model. And even though we've renamed them all and changed them all between the 2 different building models, we've tallied them up because they're in the same space. That's a kind of example. I guess there's no human in the loop here. We run a process, and it will map between old version and new version and give you some data you can start to draw new knowledge from. So I think that's pretty much what I want to show you today. Just to summarize what I've shown you, I think there's a lot of wastage, I guess, in the industry at the minute. A lot of manual effort, particularly working with BIM data and getting it to a good standard. We think there's a lot of opportunity through efficiency savings and for new services to give clients better data. I think Flow is a really good tool there to you can take a look at to automate some of these processes, from the most basic thing of how to actually see what is in that building model, to some more sophisticated model checking. And in that last example, we showed you essentially mashing up different data sources, deriving new value, in this case a carbon assessment, in a fully automatic way. So equally, we've got our Flex platform, which is really an underlying AIM service to manage building data. So if you're interested in what you're seeing today, by all means, drop us a note and we can have a more in detail conversation, give you access to our Flex trial.